Okay, guys. So last video we looked at linear inequalities, and so we'll do a little mini review on that one, and then today we're going to move into systems. Okay, so Unit 5, systems of linear equalities, and now this isn't much more difficult than inequalities. Hold on, I can't spell and talk at the same time. So I probably can't spell anyway. But this isn't much more difficult than what we did before. It's just that now, right, we're going to be putting two or more, right, two or more inequalities, linear inequalities, on one graph. On one graph. Okay. And so what we're looking for is a solution region. So there's a region on the graph that is going to include all solutions for the system. The solution region is the overlapping shaded region. Okay, and you'll see what I mean here in a second. But to review, right, we have our symbols, right? We have our symbol guys. And we need to make sure those guys stay consistent. So over here, we have the greater than or less than guy. He is open circle, parentheses, and he's got a dashed hairline there. We've got the greater than or equal to or less than or equal to. He's got a closed circle, and he's got our brackets for interval notation, and then he's got a solid hairline. Okay. So those are our guys, right? Those are our symbols. We could, and I might in the future change these up just a little bit, but we just remember that all of these things go together, right? If we have a greater than or equal to or less than or equal to, I'm going to be looking for a solid line on the graph. I'm going to be looking for brackets and interval notation, and I'll be looking for a closed circle if represented on a number line, just talking about a single solution to a inequality. So all those things are connected together, right, through our guys. So let's look at a example system, okay? And all of this will be done by graphing, okay, so that we can look at the shaded regions. Okay, so I've got, let's say 6x plus 4y is greater than 12. And I've got 3x minus 4y is greater than 8. All right. And so we are going to be graphing to find the solutions here. And so we need to have each one of these into slope-intercept form. Again, pay very close attention. We're going to write this down again. Hopefully you already know what I'm going to say, right? I'm going to write this over here on the side. Multiply, divide by negative, right? Watch that. They always try to slide it in on us, right? We have to flip the sign. Now, write this down. Even if you say, oh, yeah, I remember that. I know that, okay? The more you talk about it, the more you write it down, the more you address it, the better. Because eventually, right, you're going to just miss that. I'm the teacher per se, and I do it all the time, right? It's easy to miss. So in this one, I know I'm going to move that 6 over, and so I've got some converting to do. I'm going to move that 6 over. That's going to give me 4y greater than negative 6x plus 12. Divide everything by 4, so we get y is greater than negative 3 over 2x, and then plus 3. Okay, so negative 3/2 plus 3. And then that was because, again, I divided by 4, and 6 over 4 would simplify to 3 over 2. Then we have this other one that we need to convert as well. So I'm going to move that 3x over. So I've got negative 4y greater than negative 3x plus 8. And you can see here where just showing that one movement leaves me with this guy. And I'm going to need to divide by a negative 4. So that inequality symbol is going to flip. Now, there are some indicators. It's positive because I have a negative 3 and a negative 4, and then a negative 2. When I go to graph this, if I was to have forgotten that this flip needed to happen, my shading would look different, okay? It may still overlap, but in a lot of cases, it's going to cause a situation where your zone of solution, right, is incorrect. And we're always going to test 1 point from that zone. Okay. This will be the one time I want to make sure, right, because you've got lots of possibility here to do something wrong. So a little sketched out graph, nothing fancy, nothing super accurate, just trying to keep things somewhat proportional, right? Going to graph that top line first. So I've got y-intercept of plus 3, and I've got a slope of negative 3/2. So starting here, okay, plus 3, and then negative 3/2. That's down 3 over 2. I know that's my next one, right? Down 3 over 2. Put me somewhere right in here. And again, looking at the symbol, it was a dotted line or a dashed line before. It's not all of a sudden going to become a solid line. So just going to kind of put a dashed line through just like that. And then the shading, right? This one says greater. So I'm looking at my y values that are greater than this line. And if you'll recall, right, they get greater as they go up. So I'm going to shade that way. And again, just going to keep perpendicular shading. Now you can get as fancy with this shading as you want to, but you know, I'm a minimalist, so we're gonna just do the perpendicular lines to, right, what's there. All right, so there's that one, right? Anything on that side of the line, and not including these points on the line, right? Can't be on the line for solutions. That is going to be my shaded region. Okay, so one down, one to go, right? Now we need to do the other line on the same graph. So we've got negative 2, so I'm going to put a dot right there. The slope is positive 3/4, so up 3 over 4. So I'm right in that area there. And I could go up 3 over 4 again, but given the accuracy of my graph, it's probably not going to be in a good line. So there's the other line, right, that I've got. And now again, I'm looking for anything less than. So we're going to be down in this area. And you can see, right, now all of a sudden I've got this cross-hatched region where I should have double, right, where it's going to work for either. Whereas this region, right, works for one of them. This region works for one of them. This region works for none of them. And this region is going to work for both, okay? Like I said, pick a point in here, an easy point. So I'm gonna say 1, 2, 3, 4, 5, 6, 7, 7, right? 7, 0. I'm gonna try this point right here just to see if it works, right? I'm gonna try 7, 0 just to see if it works. Make sure that I shaded correctly. Go all the way back to the beginning to try this out. And so 7, 0 is an easy one because it kind of blocks out my y values there. So 6 times 7 is 42. Is 42 greater than 12? Yes. 6 and then 3 times 7 is 21. Is 21 greater than 8? Yes, I know that point works for both, so I know my shaded region is correct. So if for whatever reason, right, we had forgotten to switch this symbol, we would have shaded the top, which would have left this region, right, as my overlapping region. And so then I still pick, right, a point in that region. So in that case, right, 3, 4, 5, I could have picked 0, 7, right, which is this point right here, nice and safely in there. And I would have tried that one. And then I came up here, okay, well, 0, 7, that gets rid of it, right? Is 7 times 4 greater than 12? Yes, it's 28. Is negative 4 times 7 greater than 8? Well, negative 4 times 7 is negative 28, which is not greater than 8, which means that point does not work for both linear inequalities here. And I would know my shading was incorrect, okay? So very important to try a point, okay? Pick a point in your shaded region, in your double shaded region, and just try it to make sure that your shading is correct. And pick one that's well into it. Don't try to get cute and get too close to the line, because sometimes you just graphed it funny, maybe a little bit disproportional, and it's going to cause it to look like it's inside, but really it wasn't. And then you tried it, and then it didn't work, so you thought your shading was wrong when it was really right all along. Your graph was just not drawn very accurate. Okay. So that's how those are going to work, right? We're going to switch those into slope intercept form. We're going to graph them, and we're going to look for the double shaded region. Now, you can get as fancy as you want with the shading. In the future, you have to manually graph these. I will go over calculator functions and things like that, but right now, that's the only way we want to look at the solutions here for the inequalities is the graphical version. So you can get as fancy as you want. You can use colors. You can use different, you can star this one and circle that one and see where you have stars and circles in the same area, however you want to do it. Okay. But always try a point from that region to make sure that you've got the shading correct, or you're picking the correct answer choice with the shading. Okay. Any questions, comments, concerns, guys? Again, as always, just give me a message and I'll get back to you as quick as I can. All right. Thanks, guys.